So for today's live stream, it got broken up. So it crashed and the first part was not saved. So this video right here, there's going to be two parts. The first part is going to be very short, just covering question A. And then then the second video will be a much longer video going over the rest of question 5 and answering some multiple choice questions. So really the second video is the heart of today's live stream. The first one is just kind of taking care of the crash. So let's kind of go over this. Please note that I have put up in the announcement section the schedule for next week. So do go look through the schedule for next week so you know what's kind of going on and what I expect you to do and stuff like that. Okay, so let's go through this. So concert tickets went on sale and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function. This is important. Because it is twice differentiable, that tells me that this function is continuous over its domain, which is super important. It's also differentiable. You can take the derivative of twice, which is good to know too. Values of LT at various times are shown in the table. So the first thing, as always, we always talk about what are we looking at in terms of our function, our table, or our graph given. In this case, the question is, what is this? This function right here, this function that they've given us in the form of a table, what is it? Is it a position function, a velocity, or an acceleration function? So I asked the people in the stream to tell me what it is, and you should pause this right now and determine what you are looking at. Are you looking at a position? Are you looking at a velocity? Are you looking at acceleration? Okay, so in this case, we are looking at a position function. And the question is, you might ask was, well, how did you know that? The way I knew that was by looking at this, specifically the units. The units are people, right? Number of people. There's 120 people. There's 156 people. That is a position function. If the units were people per hour, right, that'd be a rate of change question. So that would be a velocity question. If it was, which would be kind of weird, if it was like people per hour squared or people per hour, that would be an acceleration question. Okay, so really, in this case, look at your units. If they don't tell you directly, look at your units. Okay, so let's do this first part. Use the data on the table to estimate the rate at which the number of people waiting in line was changing at 5:30. So they're asking us for the rate. Now notice the rate. This is important. In fact, they kind of separated this, but these two really go together. The rate changing. That's a rate of change. So they're asking us to estimate the rate of change at time 5.5. So I'm going to go up to my table and I'm going to note that 5.5 occurs somewhere in here. So what am I going to do? I'm going to find the slope of the line. I'm going to approximate that value. So in other words, I'm going to say L prime of t is approximately equal to, right? So I'm going to approximate this value. So it's approximately equal to the slope of the line from time 4 to 7. So in other words, it's going to be equal to, or I should say, it's not going to be equal to. It's going to be approximately equal to time 7, from time 7 to time 4 of this, right? So it's going to equal that slope. And if you go and do that, I did actually do it, you're going to get, this is equal to 150 minus 126 over 7 minus 4, which equals 8. And our units are people per hour. It is really important that we include the units because they asked us to. Okay, the reason it was people per hour is we were taking the number of people, dividing it by time, so people per hour. Okay, so that's where this stream ended, and the next one picked up in the next video.